Greetings and welcome to another Dev Bootstrap screencast. In this screencast, we're going to cover the Liskov Substitution Principle, and it's part of solid principles, which we covered already in other screencasts. And so this is a series that we're going to cover all of the solid principles. And today we're going to look at this Liskov Substitution Principle. And so the Liskov Substitution Principle is basically that we should, when we apply interfaces in our application, that we should effectively not be changing the correctness of the system. And so what is the correctness of the system? Well, ultimately the correctness of the system is application specific. Okay, it's based on the specifications of the application. But one sort of very simple, very high level idea is that any software system should not crash. Pretty straightforward, right? So if a client uses implementation A of an interface and the system does not crash, but then they use implementation B of the same interface and the system then does crash, then you can say that you've effectively changed the correctness of the system. Now, that's a very high level and generic explanation of this. So let's delve a little deeper with some examples. And by the way, talking of examples, everything is inside this repository here. I've covered all the solid principles, and you can click on the Liskov Substitution Principle folder here, and that takes you into the folder, which opens up a README specifically for this principle. So let's head over to the code editor and take a look at an example. So I think what we should do really is understand when the Liskov substitution principle is violated to really get an understanding for it. And one smell, if you like, to look for in your code is when you are throwing a not supported exception or similar, something like this, something like that represents a not supported exception in your programming language. So in our case, we're using Typescript. So you can see here, and I'll go through this example in a bit more detail in a second, but you can see here that we've got a class called SQL Store. And this SQL Store class implements iStore. Whoops, apologies. And so by implementing iStore, we implement the save method, the read method, and we implement this getFileInfo method. And notice that I've put here in the comments that this breaks the Liskov substitution principle. And actually, in order to fix this, we will need to go and look at the next principle, which is the interface segregation principle, but we'll be covering that, as I said, next. So I think we should try to understand why or how did we get here? How do we end up with a class that implements an interface that seemingly seems on the surface to be okay, but we end up breaking the Liskov substitution principle? And so if we take a look at where it all started, and it all started with this. It started with our file store class, because if you think about the journey, we have this application, and we've been asked by our client, by our boss, to basically implement a new storage mechanism for our messages, because our application is storing messages, right? And the current implementation, which is the file store implementation, stores these messages onto disk. And so we've gone ahead and thought, well, okay, let's create an interface that represents a store, and then we can create any new stores that by simply implementing this interface on any new store. And so we've, let's say, bluntly gone ahead and created this interface here, right? I say bluntly because we literally just extracted all the interface methods from the existing file store without really thinking about it, without really thinking about the consequences. And this is what leads to breaking the Liskov substitution principle. And so you can see here that this iStore interface has the three methods from the file store class, which is save, read, and getFileInfo. However, when that's applied to our new SQL store class here, which might be, say, for saving data to Postgres or MySQL or some other similar database, we can see that the save method is fine, the read method is fine, but then, oops, we don't need get file info, but we need to implement it because we've implemented the iStore interface. And so we're left with the unfortunate situation where we need to throw in our Typescript application, we need to throw this sort of error that just tells the implementer that the method is not implemented. And this is not good. This is breaking the correctness of the system, and it's breaking and violating the Liskov substitution principle. And so what can we do about this? How can we fix this? Well, that is the next principle, as I mentioned. So we actually are able to fix this, and we'll look at that in the next video, which is the interface segregation principle. But for now, it's important to be aware of and to understand the implications of the Liskov substitution principle and to not violate that principle as best we can. And I think that actually summarizes and finishes this screencast for now. I think that gives us a good sense of what the Liskov substitution principle is and how to avoid breaking and violating that principle. So I'll see you in the next video where we cover the interface segregation principle, and please hit the like button if you like this, subscribe, and take care and have a good day. Thank you very much.